Hello, everyone. My name is Nabil Ghayur. I work at the University of Pikeville in Pikeville, Kentucky. I'd like to thank the organizers of this symposium for giving me this opportunity to give a short talk on my poster, which is on effects of fractions of 70% methanolic extract of fresh ginger on the tone of gut smooth muscles. So as we know, ginger is a very popular and common food product, rhizome, which is used for its cuisine properties and as an herbal drug. There are many studies that have been published on this natural product regarding its medicinal properties. I have already published some of my work on the ginger, on fresh and dried varieties of ginger, and particularly for the fresh ginger 70% methanolic extract. In this study, I will be going over the pharmacological actions of the fractions of that crude extract of fresh ginger. So we prepared a 70% methanolic extract of fresh ginger. This was further subjected to fractionation through which we produced and obtained a petroleum fraction, a chloroform fraction, an ethyl acetate fraction, and an aqueous fraction of the crude extract. Now, all these fractions were then tested upon isolated smooth muscle tissues like rat stomach fundus, rabbit jejunum, guinea-pig ileum, and guinea-pig trachea. This is the picture that is showing the process of extraction, where a crude extract was formed, and then this crude extract was then fractioned with different organic solvents like petroleum spirit, ethyl acetate, chloroform, and then a final aqueous fraction. And this is a picture that shows how these tissues were isolated and they were mounted in these tissue baths, and then contraction and relaxation of the tissues were obtained under influence of these fractions of fresh ginger extract. This picture shows some thin layer chromatography showing that the crude extract, the crude extract from which different fractions were obtained, the crude extract had saponins, flavonoids, and alkaloids present in it. Now, the next 4 or 5 slides will show us the results that we got from the different fractions of the crude extract of fresh ginger. So this is the slide showing the results from the petroleum spirit fraction. We show that this is a control tracing of contractions of rabbit jejunum. When increasing concentrations of the petroleum spirit fraction were introduced, we see a dose-dependent increase in the relaxation of the tissue. The same kind of idea we also are seeing over here. Increasing concentrations of the fractions reduces induced contractions from potassium chloride, indicating that probably there is some kind of a calcium channel blocking activity, which is also comparable to a standard calcium channel blocker, verapamil. These curves show the relaxant effect of the petroleum spirit fraction in the spontaneous contractions and the K-induced contraction or potassium high K-induced contractions. There's also a comparison of the relaxant effect of this petroleum spirit fraction compared to the crude extract. So we see that there is a significant pronounced and a more potent effect from the fraction when we compare it to the crude extract. There's also some curves over here that show that when these calcium chloride curves were produced in rabbit jejunum in a calcium-free medium, the increasing concentrations of the petroleum spirit fraction reduced or suppressed these curves, confirming our finding that the relaxant effect of the fraction is related to a calcium channel blocking activity. The fraction was also able to reduce the contractions of carbachol, which were induced in guinea-pig trachea, which show that it has some airway relaxant activity as well, which can be beneficial in hyperactive states of the airways, like asthma. Now, this slide shows just one set of experiments for the effect of the chloroform fraction in rabbit jejunum without any additions of any other chemicals on the spontaneous contractions. There was a dose-dependent increase in the contractions of the rabbit jejunum, which means that there is some kind of a stimulant effect from this fraction, although in higher concentrations, again, in increasing concentrations, there was a relaxant effect. This relaxant effect was also seen when the fraction was introduced on potassium-induced contraction, showing that this relaxant effect is of calcium channel blocking activity mechanism. This slide shows the results from the ethyl acetate fraction of this ginger extract, we see that when this was introduced on baseline or just a resting baseline of rat stomach fundus, which is a stomach tissue, there was dose-dependent increase in the contractions. There was a little bit of a decrease when this was challenged with atropine. So it means that there is some kind of a cholinergic component, although we were not able to quantify or we were not able to characterize the receptors that were involved for the effects seen from higher concentrations. The ethyl acetate fraction was also able to show contractions of rapid jejunum, which were blocked by atropine, which is also shown here. And the relaxant effect that came at higher concentrations was also seen with high K-induced contraction, again showing a combination of cholinergic and calcium channel blocking properties. The stimulant effect of this fraction was also seen in the ileum, guinea pig ileum preparation, which is completely blocked by atropine, again showing that this is mediated through the muscarinic type of cholinergic receptors. Finally, the aqueous fraction, again, on the stomach fundus, a baseline, increasing concentration showing a stimulant effect, which was only partially blocked by atropine. So maybe there were some other receptors that were involved for the stimulant effect. In rapid jejunum, again, a pronounced stimulant effect, which is only partially blocked by atropine. And again, in ileum as well, only partial blockade of the stimulant effect of this aqueous fraction. We were also able to compare these results with some of the known chemicals that are known to be present in ginger, shogalls and gingerols. Different varieties of gingerols and shogal were tested, and we see that in rapid jejunum spontaneous contractions, there was dose-dependent reduction from all these compounds. They were all also able to reduce the high potassium-induced contraction. And in rapid fundus tissue, on the baseline, there was a little bit of a stimulant effect, dose-dependent again, and there was also a reduction of the potassium-induced contraction. So again, the same kind of effects that we were seeing from the fractions data. Now, this is pretty much the last slide that shows the big picture. I wanted to make a comparison of the effects that we've seen from the fractions compared to the already published results from the crude extract. We see that throughout all the tissues, the crude extract showed relaxant properties in rapid jejunum, aorta, guinea pig ileum, guinea pig colon, guinea pig trachea, atria and trachea. In rat stomach fundus, there was a combination of stimulant and relaxant properties. In rat uterus and ileum was also relaxant properties. Now, when we see the fraction data, the petroleum spirit fraction only showed relaxant properties. The aqueous fraction only showed stimulant properties, mostly through cholinergic receptors, although the chloroform and the ethyl acetate fractions showed a combination of stimulant and relaxant properties. So this shows that there is a combination of spasmolytic and spasmogenic potential of not only the crude extract that we've already submitted and published, but also the fractions from this crude extract. Mainly, again, the main point, the petroleum spirit fraction is mostly relaxant in its pharmacology, and the aqueous fraction showed mainly the stimulant effect. I hope that this was beneficial. And if there is any questions, you can always reach back to me. My email would be available on the University of Pine Cold's website. Thank you so much.